Okay, so anytime we start these functions, we always start in the same way, if it's necessary. We would start by looking at the top. If it's possible, we would factor the top and factor the bottom. So factoring is always the way we start these problems. After you factor, you try to identify your holes. And the holes are identified by factors that you see where? Top and bottom. So factors that are on top and bottom. As I was walking around, I saw a couple of people write the word factors that cancel. I think that's another great way to think about it, because if they're canceling, that means there's one on top and bottom. This isn't, this wouldn't be a test question where I'm only going to accept one thing. It's what makes sense to you. So what makes sense to me is I look for factors that are on top, factors that are on bottom. Those are what create my whole. The same on top and bottom is good too, as long as you're making sure that you see it on top and bottom. Yesterday I tried really hard to emphasize this point right here. After you find those holes, you want to rewrite the function ignoring those holes. So kind of cross them off and take the time to rewrite a new function that does not include those factors of top and bottom repeats. Okay, after you do that, the reason we do that is because you really don't need those factors ever again. And so from here forward, you're going to use that new function. So in that new function, you're going to look for vertical asymptotes. The vertical asymptotes are the factors that you see now on the bottom. That's too big. And then after you find your vertical asymptotes, those are vertical lines, so it's going to be x equals some number. After the vertical asymptotes, then we typically do the horizontal or the slant. This is the based on the degree. This is our saying, where we look at the exponent, the highest exponent you see on top versus the highest exponent you see on bottom. So our saying that we have is high over low, slant we will go. And yesterday we started doing these slant equations. And the equation ended up being the equation left over after division. And so yesterday what we were seeing is that if you had a hole on top and bottom and you canceled those out, then you had divided the equation fully. And so then what was left over was your slant asymptote. Sometimes we'll have a degree, low over high, and this is 0 equals y, so you'd have a horizontal asymptote at 0 equals y, or y equals 0. And when they're the same, we played the coefficient game. So I know a lot of you know to say the coefficient game, but you don't necessarily know what the coefficient game is. So what the coefficient game is, if you look at this example, I have f of x cubed plus 2x squared minus 1 over 2x cubed minus 7. So I do indeed have highest degree of 3 over highest degree of 3. They're the same. I play the coefficient game. The coefficient game is the 4 over the 12. So I say y equals 4 over 12. But is that the best possible answer? 1/3. Okay, then we look for our x-intercepts. How do you find your x-intercepts? Solutions on the top. These are found by solutions on the top, or factors on the top, however you want to say that. And if you want to remind yourself really quickly right here, I want to see a number, comma, 0 for x-intercepts. You need to remember that x-intercepts are a coordinate x, comma, y point. So whatever the number is, comma, 0. And lastly, we find our y-intercepts by plugging in x equals 0. And you can plug that in into any equation you want. And so again, I want to remind you it's 0, comma, some number here. Okay, so as a review, let's go over what we did yesterday. So if you weren't here yesterday, try to get as much information as you can from this example. Yesterday we learned about slant asymptotes, but we only looked at slant asymptotes that divided evenly. So what I mean by divided evenly is that when you factor the top and factor the bottom, everything canceled. So as a review from yesterday, let's go ahead and do that. Like we just said, our first step is always to factor. So if I factor this equation, I have f of x equals, and hopefully you can recognize that difference of squares pretty quickly, x plus 5, x minus 5, and I have x plus 5 on bottom still.
Is our test going to have anything on the last test, or is it all just this?
You're going to see. So, as soon as I factor, the next step is to look at those factors and determine if one repeats on top and bottom. So I do, in fact, have x plus 5 on top and bottom, which creates a whole at negative 5. Negative 5 comma something. So in order to figure out that corresponding y value, this is where I take the time to say, well, I don't want f of x to be that thing anymore. I'm just going to simplify f of x to x minus 5. If you want to put it over 1 just to make sure you keep that like that, that's fine. It doesn't hurt you to do that. So what I'm trying to do is get this corresponding y value right here. And I know x is negative 5. So I'm going to plug in negative 5. I got to subtract 5. Negative 5 minus 5 is negative 10. So I have a hole at the coordinate point. X is negative 5, y is negative 10. Next, vertical asymptotes. These are the factors found on the bottom, but after I factored, I find that I don't have any factors on bottom. So what is the best possible way to write that, or what should I write? None. Write the word none. That is very clear that there are none, not 0. Okay, my horizontal asymptote. I tell you it does not matter which equation you use. If you look at this equation that we're now using, I think that that's the simplest one. You have x to the power of 1, and there's no x's on bottom. You could think of that as x to the 0 if that helps you. So you have high over low, slant we will go. So I'm going to just circle the slant, SA. And once again, yesterday we talked about how do you get the equation for the slant. The equation for the slant comes from the division. Well, crossing off is dividing. So I've already divided. There's nothing left on bottom to divide. So x minus 5 is my slant asymptote. Y equals x minus 5. My x-intercept is found by the root that's still on top. So x minus 5 set it equal to 0 is 5, comma 0. And my y-intercept is 0, comma. Now if I plug in, I need to find the corresponding y value, so plug that in, subtract 5 is negative 5. Is everybody okay? Okay. So let's graph this. I usually start with my horizontal asymptotes. There's no particular reason that I do that. I don't know, do. So, I am going to graph x minus 5. So this is a linear function, mx plus b. So my slope m is 1 over 1, my b is negative 5, so I'm going to start 5 down. One, 2, 3, 4, 5. This is really hard for me to do, but you should try to go with as straight of lines as possible. It's going to become really important today. So if I could, I would be using my badge. I can't really do that, but I would recommend you all use your badge. A slope of 1 over 1 says I go up 1 over 1. Up 1 over 1. Up 1 over 1. So I'm going to go up 1 over 1 the entire time so I don't have to guess what I meant. Because my lines are not great on this. Yeah, but I think it's too thick. Okay, there's my horizontal asymptote.
So you're not going to make it dog form like you did yesterday?
Yeah, I really don't like that the more I look at it. Sorry if you're listening to this recording. Don't do that. Let's just make it like this. Again, you need to use a straight line. It's really important in today's lesson that it's a straight line. Okay, I still need to graph my hole. So my hole was at -5, -10. So I'm going to plot the point -5, -10. And make sure you draw an open circle there. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should see that your hole is right on top of that line. If you did a very straight line, it should be that way. I need to graph the x-intercept at 5, 0. Again, that's going to be on the line, and -5, 0. So yesterday we talked about this. When everything cancels out, you can see that all of your dots are just lining right on top of that slant asymptote. That is not coincidental. These are, in fact, the same. The blue is your function. The red that is now kind of covered up was that slant asymptote. That is supposed to happen in this case. So my domain is -infinity. All I have to skip is that hole at -5.
So when we're graphing it, do you want us to do the bottom line, then solve all of it?
It doesn't really matter. I mean, on this one, because they just go right on top, it would be obvious to me. But whatever you feel comfortable with. Okay, so let's go on to our next page. So once again, in class, before we started, I did ask you to change this example 1 to +14. It is a typo that you should have changed. Make sure that's changed before I start this. Okay. So yesterday, every single example that we did, you crossed off something on top and bottom, and there was nothing left on bottom, which meant that there was no vertical asymptote, and really you didn't end up having to divide. What I mean by you didn't really have to end up having to divide is, I introduced this idea yesterday. If I asked you what 8 divided by 4 is, you can all tell me it's 2, but the reason why it's 2 is because you have 4 times 2 over 4. These cancel, leaving you with 2. But what we're doing today is we would do something like, what is 18 divided by 4? And if you tried to do that, well, 18 is 9 times 2, 2 times 2. Only this thing cancels, which means that you have to do 9 divided by 2 in your head, or however you would do that, and you get 4.5. So that's kind of what we're doing today, is rather than everything just canceling like it did here and getting the straight answer, if not everything cancels, you have to still do a division to get the answer this way. Now we're just going to apply that with polynomials rather than numbers. With numbers, it's easy. Polynomials, we know how to divide. So, Terry, you asked if we're going to have to do stuff from the last unit. This is why we studied synthetic division and long division. Because if you have to divide polynomial division, we use synthetic or long. For the most part, it will just be synthetic if that's your preference. Okay, so yesterday we were crossing off. That is a form of division. We were just doing the easy form of division. So if not all factors can cross off, we will be forced to divide. This is what I was just talking about. However, you can still cross off as much as possible before you start dividing. That'll usually make it a little bit easier on you. But you don't always have that chance. So let's go ahead and start. We always start by factoring. So let's factor this equation. Now that I've changed it to +14, 1 times 14 is 14. multiplies to 14 yet adds to 15 is 14 and 1, both negative. So hopefully you can do this. X squared minus 14x minus 1x plus 14. You should not be looking at what I'm doing because you are so awesome at this yourself, and you don't want to look at my ugly handwriting on this. So x minus 1, x minus 14. And on bottom, that doesn't factor anymore, so just x minus 3. So, this is a very good order that we give this to you in. First, you try to identify your holes. Do you have any holes? No. So, I'm just going to write none. Do I have a vertical asymptote here? Yes, at x equals 3. I still have a factor in the bottom now. So x equals 3 is my vertical asymptote. Will I have a horizontal or a slant asymptote? It is a slant. This is a high over low, because if you are looking at this factored form, the degree is not just x or x. This is going to multiply to get you x squared. So you do have high on top, low on bottom, high over low, slant will go. And because there was no easy cancellation here, we have to divide ourselves. So how can I divide top divided by bottom? Yes, we have never learned, and there is no way to divide when you have the factors. So this is the downside to factoring first. It's more good than bad, so still factor first, but you cannot use this to divide. We're going to have to FOIL this out, or if you FOIL it out, what should you be getting? Right, back to the top. So you could also just do this divided by this. I don't see anything wrong with synthetic. So if you want to use synthetic, let's use synthetic. So I'm going to enlarge this just to make it a little bit easier for me. So I have a 3 that goes in the little box. It was x squared minus 15x plus 14, because that was supposed to be a plus 14. Bring down the 1. 3 times 1 is 3. Is negative 12. Is negative 36. Is negative 22. Makes sense that that's a remainder because that was not supposed to be a factor. So we do have a remainder, we have a number, and we have an x. So what's left over is the linear function x minus 12 with a remainder of negative 22. So what we just did is the worst part. We are going to have to start dividing. But I have good news. And the good news is that the remainder over time makes no difference. It's like complaining about 10,000th of a penny. I'm not saying 10,000 pennies, but I'm saying like not even a full penny. It's like complaining to the bank that they didn't give me half of a penny. It really over time does not matter. So we're just going to end up throwing away the remainder. And so our slant asymptote is going to be x minus 12. Y equals x minus 12. So while you do have to do that synthetic division, it's not quite as terrible as maybe you remember when we first learned synthetic division. Okay, how do we find x-intercepts? This is where we're at. Top. So I have 1 and 14. 1 comma 0 and 14 comma 0. And my y-intercept, that's found by plugging in a 0. So if I put 0 here, 0 here, and 0 here, 0 here and 0 here makes negative 1 times negative 14 is positive 14 over negative 3. So 0 comma negative 14 thirds. Positive 14 over negative 3 is the same thing as negative 14 thirds. I just prefer to put my negatives on top. 14 thirds is, well, 12 thirds would be 4. 15 thirds would be 5. So this is negative 4.5-ish. That's as good that you have to get. You don't have to get any better than that, okay? All right, let's graph all this. So I don't have a hole to graph. I start with my vertical asymptote, x equals 3. So x equals 3 is my vertical asymptote. 1, 2, 3. And I have a slant asymptote at x minus 12. This is just graphing a regular linear function. My y-intercept should be negative 12, and I will go up 1 over 1 using straight lines. And I do apologize that this goes off the graph. I wish it wouldn't, and I don't think the test will. So 6, 7, 8, 9, 10. I need to go down 2 more. 11. That's 10, 11, 12. And it's really hard to make straight lines when you don't even see where you're going. But I think it should look like that. Is that about what y'all have?
Yes.
Okay. 1, 0. $14. So this is 10, 11, 12, 13, 14. It'll be past that orange. Again, I do apologize. That's kind of hard to see. Negative 14/3, we said that's about negative 4.5. So 0, 1, 2, 3, 4, and a little bit. 4.5 or so. And what I kind of like to do when I'm graphing these is think of these as quadrants. This is like a quadrant here. This is like a quadrant here. This is like a quadrant, and this is like a quadrant. So I usually start with the quadrant that I know the most about. So I know 2 points inside of this quadrant. So I would start there, and I would go ahead and connect those 2 points. And as I can kind of see, I mean, I'm going up, so I'm going to continue to go up, and then I'd come around. There's really only one way to go about that connection right there. Remember that this is the vertical asymptote from x equals 3. I'm about to ask you about a multiplicity. Do you know what I'm asking about multiplicity? So if this is the vertical asymptote of x equals 3, it came from the vertical asymptote or factor of x minus 3. Is that a single or a double multiplicity? Single. When you have single multiplicities, or odd for that matter, you have an up arrow, and on the other side of that vertical asymptote down here, I should have a down arrow. So the odd multiplicities have ups and downs. So that means this will be going down, and I've got to cross that, which makes it all makes sense. I mean, that downward allowed me to cross that point as well. Okay, and so our domain, it looks like as I go, if I start on the left-hand side, everything's defined over here. But as I move to the right, I don't get to pass this point at x equals 3, so I'll skip that, but then everything after that is okay as well. So negative infinity to negative 3 union negative 3 to infinity. That's a positive 3. Thank you. Okay, let's do another one. So we always start by factoring. Looking at example 2, how do I factor example 2? Or the top, at least. It's a cube rule. These cube rules, let me just be upfront, are going to come up a lot. They are really good examples that make really pretty graphs, so we use them. So your cube rule. You all may remember cube rule's different. How I've always said the cube rule is you're going to start with a binomial, something with 2 things in there, and a trinomial, something with 3 things in there. Then I would apply my SOAP rule to tell me my pluses and minuses, where the S here stands for same sign. So I'm looking at the sign right now as plus. So same sign is plus, opposite, minus, always positive. So same sign, opposite sign, always positive. Then I fill in my kind of, so to say, blanks here. The cube root of x cubed is just x, and the cube root of 8 is 2. So what goes here is x. Just that first thing. What goes here is just that second thing. What goes here is the first thing squared, the first times the second thing squared. This is what I'm calling the first and the second, okay? So I have x plus 2, the first thing squared, x squared, minus first times the second thing squared. All over. And I'm just going to factor this. If you need to take longer to factor, that's perfectly fine. I'm just wanting to make sure I get through all my notes. Okay, so after I factor, I look for my holes. I do see that I have the factor of x plus 2 both on top and bottom. So that gives me a hole at -2, comma, and I need to find out what that comma or that corresponding value is. So I'm going to cross off those x plus 2's. I'm going to rewrite my function as x squared minus 2x plus 4. And all over x minus 1. When I first introduced cubes, I told y'all about this, but it didn't end up mattering that much. It really matters a lot now. I am not even going to attempt to factor this. It is just a definite, always rule that once you apply your cube rule, this quadratic, the second part, will never be factorable. Period, end of story. You don't have to check it. Furthermore, not only is it not factorable, but even if you tried to apply the quadratic formula, it would always give you imaginary numbers. Again, period, end of story. So that really helps us out a lot because I don't have to think about this. I know that's as far down as it's going to get. All right, so let's put in -2 for all of my x's. So here, here, and here. And we're going to evaluate. So I have -2 that has to get squared minus 2 times -2 plus 4 all over -2 minus 1. So -2 squared, that's 4 plus 4 plus 4 is 12. And here I have -2 minus 1, that's -3, which reduces to -4. So -2 comma -4 is my hole. My vertical asymptote. Even after I've rewritten it, I'm going to cross this off so I don't get confused. So even after I've rewritten it, I do still have a denominator, and that denominator is x minus 1. So x equals 1 is my vertical asymptote. I have a horizontal or slant asymptote. Which one in this case? It is still slant. I have degree of 2 over degree of 1. High over low, slant we go. Even after I've crossed off, I still have this denominator that I have to divide. This is our new thing we're doing today. We're doing synthetic. So I'm going to divide out that 1, that 0 of 1, 1, -2, and 4. Bring down my 1. 1 times 1 is 1, minus 1 makes 3, which I just continue to go on because I'm used to it, but as it turns out, we really don't need that remainder. So this is the number and the x. So y equals x minus 1 is our linear slant asymptote. X-intercepts. These are the factors you find on top. I just talked about this. So there would not be any. If this is going to give you imaginary numbers, that is not something you can plot. So we say none.
That's if it can't be factored.
Yes, and we know for a fact it can't be factored because it came after the cube. In my y-intercept, if I plug in 0 here and here and here, I would just have 4 over negative 1, so it's 0, comma, negative 4. All right, so let's graph all of this. I have x equals 1 as my vertical asymptote. I have x minus 1 as my slant. This is the one that it's really important that you use a straight line. So I am going to try and do that as well. I'm just going to do that because I'm probably not going to be able to connect that better. My y-intercept, or where can I start? I guess I'll do my whole is at negative 2, negative 4. So negative 2, negative 4, so you can already see that using that straight line is helpful because that's just barely below that line. If you don't use a straight line, you may not know if it's above or below. What haven't I done? I haven't done y-intercept is 0, negative 4. All right, y'all are kind of acquainted with these graphs by now. And again, kind of think of these as quadrants. Here's a quadrant, here's a quadrant, here's a quadrant, and here's a quadrant. This is the only quadrant that you know anything about. Have you ever seen one of these that just have like a straight line going across? No, they usually have some type of curvature going on. How can you apply a curvature? Show me with your hands. Yeah, it's just going to be an upside down U. So this was the vertical asymptote attained by x equals 1. Was that a multiplicity of 2? No, so I will have an upward arrow to match that downward arrow. And my domain is everything but the holes in the vertical asymptote. I do have a hole at negative 2. That guy comes first. Then I would get to the vertical asymptote at 1, and then I'll go after that. These are kind of fun if you let them be fun. I know I'm a nerd, but still, they're kind of fun. All right, is that the bottom of that page? Okay. All right. That's a big one. All right, I'm going to factor super quick. You ready? On the top, when I factor the top, this is a 4-term polynomial. So if I'm going to factor the top, I start automatically by grouping. And when I pull out something from the front, I get x squared, x plus 1, minus 9, x plus 1. That's good. They match. But is x squared minus 9 fully factored? No. So I will write on top what? Very good. X plus 3, x minus 3, x plus 1. On bottom, I will just say this is x minus 4 and x plus 3. All right, so we start with holes. I do see x plus 3, both top and bottom, which gives me a hole at negative 3, comma, something. So I'm going to cross these off. I'm going to rewrite. I know a lot of you don't like to rewrite it, but it's just a little step. And it's so much easier. All right, what I'm trying to do, well, I need to get the rest of this, but this is where I'm at right now. So I need to get the corresponding y value by plugging in -3 here, here, and here. So if I plug it in, I get -3 times, or -3 minus 3, which is -6. I don't know why I wrote that. So -6. Here is -3 plus 1, which is -2. And on bottom, I have -3 minus 4, which is -7. So this is 12 over -7, or -12/7. That is a -12/7. My vertical asymptote, I do still have a denominator. That denominator is x minus 4. It gives me a vertical asymptote of x equals 4. My HA/SA, I have x squared. Whether you see it or not, it is x squared on top over x. High over low, slant we will go. And if it does not cancel, you are forced to divide. Once again, can you divide the numerator by the denominator as it stands? No. What do you have to do? You have to what? Yeah, we're going to have to FOIL it. If you are interested, a lot of people would go back up to the top and just divide those two, and you would get the same answer. What is the bad thing about going to the top? Yes, you would have to use long division here because you can't do synthetic when you have a quadratic in the denominator. But if you are not scared of long division and want to do that, you should absolutely get the same thing. But as it stands here, I'll probably do the synthetic, which means I have to multiply these two first, and then I'll divide. So that's going to be, so we're going to divide. Let's divide. And if I FOIL that, it's going to be x squared minus 3x plus 1x makes minus 2x minus 3 divided by x minus 4. So that means that 4 is on the outside of synthetic. 1, -2, -3, bring down the 1. Makes 4, makes 2, makes 8, makes 5, which doesn't really end up mattering. So this is my number and my x. So it's y equals x plus 2. It is not going to be a very complicated slant asymptote. The process itself is complicated enough, so. X-intercept, these are my factors I see on top. So I still have a 3, 0 and a -1. And on bottom, no, my y-intercept is found by plugging in a 0. So this is -3 times 1 is -3 over -4. It's positive. All right, let's graph. So I like to start with my asymptotes, so I'm going to graph x equals 4. 1, 2, 3, 4. It's right here. This is another one that's really important that you get a straight line. I'm not doing a very good job. And x plus 2. Okay, let's get my wholes. As far as -12/7 goes, -14 over 7 would be -2, so it's not quite there. So it's just barely under -2. So I have -3, almost -2. So -3, almost -2, which is going to be below. And that's a hole. Then I'm going to plot my x-intercept. That's at 3, 0. And at -1, 0. And I'm going to plot my 0, 3/4. And this one is really, really clear. There's only really one way to do this. If I connect these 3, I'm going up, and I've got to come back around. I don't really know how far into this little corner it's going to go. I certainly would not expect you to know how far into that corner it's going to go. I just need to see this general shape. And then if this has a downward arrow, it must have an upward arrow because there's no indication of multiplicity. So my domain is -infinity. Skip the hole, skip the vertical asymptote, and go on. Okay? All right, lastly, example 4, -1 approached from the right. This is -1 approached from the right. So here's -1. If I go barely to the right of that, I see a downward arrow, -infinity. This is -1 approached from the left. So here's -1. If I go barely left of that, my arrow is headed up. 2 from the... Honestly, it doesn't matter. If I look at my 2, they're both, left is going up, right is going up. Both of those are positives. Both of these are infinity as well. One's positive, one's negative. Your homework is attached. Please do a good job. You're relying on each other Monday to do everything you can do together.